Action potentials are messages that propagate electrical signals down an axon. Here is a nerve cell. Nerve cells have a negative charge, which is usually around negative 70 millivolts. This charge is due to the concentration of sodium and potassium ions. There are more positive ions outside of the cell, and less positive ions inside of the cell. Therefore, the cell is negative relative to its surroundings. Inside of the cell, there is a greater concentration of potassium ions. Outside of the cell, there is a greater concentration of sodium ions. The sodium-potassium ATPase pumps potassium into the cell and pumps sodium out of the cell. This keeps the cell negatively charged. To begin with, nerve cells are negatively charged. However, when a dendrite receives a signal, sodium begins to rush into the cell. Sodium is positively charged, and when it begins to enter the cell starts to become positive. This is known as depolarization. This depolarization triggers an action potential, and now the message can be relayed down the axon. Once the action potential occurs and the message is relayed down the action potential is terminated. Potassium flowing out of the cell causes the action potential to be terminated. Potassium is positive, and if it flowing out of the cell, it causes the cell to become negative and polarized again. The cell then waits for another stimulus to become depolarized again. This graph shows how the charge of a cell changes during an action potential. Sodium rushes into the cell and causes the cell to become depolarized. This sodium rush causes the cell to become positive and triggers an action potential. Once the action potential has occurred, potassium leaves the cell, so it becomes negative again. Therefore, the cell becomes polarized once again. The cell overshoots the resting membrane potential and makes the cell extra negative, so that it makes it less likely to fire an action potential. The resting membrane potential is then kept negative at negative 70 millivolts by the sodium-potassium ATPase.